Section 5.4, trig functions defined on the unit circle. Let's look at a unit circle first of all. What is a unit circle? Take a coordinate plane. Let's suppose take a circle with the center at the origin there. And this circle goes out to the point 1, 0, goes out to the point over here on the coordinate plane, -1, 0. So this would be the point like 0, 1. That'll be point 0, -1, okay? But the reason why we call it a unit circle is because its center is at the origin and the radius of the circle is 1 unit long. So 1 unit long. All right, let's suppose that we look at an angle theta right here, okay? This angle theta. And let me extend that a little further. And then we look at taking a number line, putting it something like this. And we're going to say the numbers on this number line are t values. And maybe we'll say something like, okay, here's a t value of pi/4. Here's a t value of pi/2. So this portion right here is positive numbers, and this portion is going to have negative numbers. So this is just a number line here, like maybe t is equal to -pi/4. All right, so think of a number line as being vertical here. All right, now this point on your number line we could look at as corresponding to this point. In other words, we're taking this number line right here and think of wrapping it around like that. The positive values and the negative values over here for the number line, think of wrapping them around like that, okay? So this t/4 corresponds to that point right there. This t is equal to pi/2 corresponds to that point there, okay? And let's suppose this point right here, well, it actually is, we don't have to suppose. Let's say it's 0, 1 right there. And this point right there, let's say that that one is square root of 2/2, comma, square root of 2/2. So they're building a correspondence here where they're saying, okay, t value of 1/4 corresponds to the point square root of 2/2, square root of 2/2. T value of pi/2 corresponds to the point 0, 1. T value of -pi/4 is going to correspond to a point right here on the unit circle, and that t value is going to correspond to square root of 2/2, comma, -square root of 2/2. All right, so they have t values corresponding to points on the circle. Now let's take a look at this formula we used in the past. S is equal to r times theta for arc length here. Let's suppose I want to look at this arc length. Let me pick another color here. I want to take a look at this arc length right here on my circle, okay? So let's see. S would be r times theta. Well, what's r in this case? What's my radius? It's 1 unit long, right? 1 times theta. So what do we know? S is equal to 1 times theta is theta. So theta right here is going to be the same as this S value, the measure of it anyway. All right, so that I'm going to look at this way now. I'm going to take that same unit circle, okay? Remember, a circle centered at the origin with a radius of 1. So this would be like the point 1, 0. This would be like the point 0, 1, and so forth, okay? And let's look at this distance r right here, my radius of my circle, I could say. And let's look at this angle theta right here, okay? Now right here, at the end of r, where it touches that circle, we're going to have ordered pairs x, y. Now, with these ordered pairs, let's see if I can name them something else, since I'm using a circle here, okay? Let's look at some trig functions. What if I take that radius over there and I say, at this point, like look at this radius right here, and at this point right here, let me drop down a line vertical right here that makes a right angle right there. Makes a right angle. Okay. So then let's talk about some trig functions of that right triangle right here. Of this right triangle. What would you say the sine of that angle theta right here is? Well, what's the sine? It's the opposite right here over hypotenuse, right? Well, what is this opposite side right there? Well, doesn't it have a length of y right there? It's the same as that y coordinate, right? What is the length of this side of my right triangle right here? Think about it. You go from 0, 0 to this point over here, you move x units, right? So let's get back to our sine of theta. What's the sine of theta? But look at theta, theta's angle right here. Sine is opposite over hypotenuse, y over r, right? Well, what is r in the unit circle? It's 1 unit long, so that's y over 1, or the sine of theta is equal to y, right? How about the cosine of theta? What is the cosine of theta? Well, if we look at this triangle right here, cosine is adjacent over hypotenuse. That's x over r. But we said if we're in a unit circle, the radius is 1 unit long, so r is 1. So the cosine of theta is equal to x. What about the tangent of theta? If I look at this right triangle here, and I look at theta right there, wouldn't the tangent be y over x? Now that's of course where x cannot be equal to 0 because it's undefined there. All right, so what are we saying? If I sum this up, I'm saying the sine of theta is equal to y. Cosine of theta here would be x. Tangent of theta, we said was y over x. And what about the other 3 trig functions? Cosecant of theta. Isn't it just the reciprocal of the sine? Remember, that's over and understood 1, right? So the reciprocal of y over 1 is 1 over y. So the secant is the reciprocal of cosine, so that's 1 over x. And the cotangent of theta would be x over y. Now that's of course here that y is not equal to 0, x is not equal to 0 here, y is not equal to 0 there. Okay, so that's how we're going to define on the unit circle the sine, cosine, tangent, and so forth. Take a look also at this. Doesn't it say if the cosine is equal to x, if x is equal to the cosine? So instead of x as my first number in order pair, I can think of that as the cosine of theta. How about sine of theta is equal to y? Couldn't I read that as y is equal to the sine of theta? So instead of a y coordinate, I can think of that as the sine of my angle theta in the unit circle. So what does that mean if I go back to this part right here, okay? Think about going back to that part. In fact, what I'm going to do is I'm going to erase it real quick so I can draw a picture without so much going on so it's easier to see. All right, so let's see what we had. We had a unit circle here, and we had those t values and so forth, right? draw this again. We had a unit circle like that. We had a theta value. We had some angle theta right there. And we also had what? These t values here. And we said like right here, t is equal to pi over 4, corresponding to that point right there, right? Then when we did s is equal to r times theta, what did we find out? S was equal to theta on the unit circle. So this s part, which is the same length as there, which is pi over 4 in this case, is the same as this angle theta right here. Now, which order pair did I have up here? I had square root of 2 over 2, comma, square root of 2 over 2. I had square root of 2 over 2, comma, square root of 2 over 2 as an ordered pair. Couldn't I look at this stuff and say, okay, my ordered pairs on this unit circle run cosine of theta, sine of theta. So cosine of theta, comma, sine of theta is what these ordered pairs look like. So what I could do now is I could look at this as, just a second, let me erase. I could look at this now as, what if I wanted the cosine of my angle here, theta, which is what? Pi over 4, cosine of pi over 4. Well, that would be, cosine is the first number in this order pair, square root of 2 over 2. What would the sine of that angle pi over 4 be? Well, the sine is the second number in the order pair, which was square root of 2 over 2 also. How about the tangent of theta? And theta in this case is what? Pi over 4. Well, the tangent is defined to be what? Y coordinate over x coordinate. Y coordinates square root of 2 over 2 over x coordinates square root of 2 over 2. That gives me what? 1, right? Didn't we also say somewhere that the, never mind, we didn't say that yet. I haven't got to it yet, I'm jumping ahead. All right, so what we do a lot of time is we look at special angles. Special angles on the unit circle. Special angles. And I'm going to draw kind of a larger unit circle here. I'm going to blow it up or magnify it, I guess you could say. And let's look at these special angles, okay? We know that this point right here is a point 1, 0 if we're looking at the unit circle. Now, what if I think about rotating through an angle of pi over 6 radians, pi over 6 radians, okay? I have an ordered pair for that. Then if I think of rotating through an angle of pi over 4 radians, pi over 4 radians, draw it a little better. Pi over 4 radians, I have an ordered pair that corresponds to that. If I think about rotating through an angle of pi over 3 radians, I have a special ordered pair that goes with that. And if I think about rotating through an angle of pi over 2 radians, I have an ordered pair that goes with that. Well, I'm sure you can figure out what this ordered pair is pretty easy. If the radius is 1 unit, what would that ordered pair be? 0, 1, right? All right, now, what are these ordered pairs? Remember that chart, those values we had to learn? We had a chart that looks something like this. Sine of theta, then we have some theta values up here like 0 with pi over 6, pi over 4, pi over 3, and pi over 2. Right? And then we said this one was the square root of 0 over 1 for each side. This was the square root of 1 over 2. This was the square root of 2 over 2. This was the square root of 3 over 2. This was the square root of 4 over 2 or 1, right? Well, what did we learn earlier? We learned in this unit circle that we have what? Cosine of theta as the first number, and the sine of the angle theta as the second number. So theta in this case is pi over 6. What is the sine at pi over 6? Sine of pi over 6 is 1/2. So the second number here at pi over 6 is going to be 1/2. What do we learn about? Now, notice I put pi over 4 here just to make it look less messy, but what pi over 4 really is this angle right here, okay? All right, let's take a look. What is the sine at pi over 4? The sine pi over 4 is square root of 2 over 2, right? So I'll put that in for the second number for the sine. What's the sine of pi over 3? Square root of 3 over 2. And the sine of pi over 2 is square root of 4 over 2, which simplifies to 1. And for the cosine values, you just go backwards. Square root of 0 over 2. Square root of 1 over 2 simplifies to 1/2. Square root of 2 over 2 goes here. Square root of 3 over 2 goes here. And square root of 4 over 2 goes there, which is 1. So what I want y'all to do is I want y'all to memorize this part of the unit circle. All these angles with their corresponding points. Now, some books and some teachers have you learn all of them in this one and all of them in this quadrant and so forth, okay? And all of them in this quadrant. All I really need y'all to learn is these here, okay? And the reason why is because we could figure out all the others if we know those. So y'all memorize those. All right, another helpful piece of information we're going to use here. So we're going to say it's an identity. Tangent of theta is equal to the sine of theta over the cosine of theta. So let's say I want the tangent at 0 radians, tangent of 0. That would be the sine of 0 over the cosine of 0 according to this identity right here. Well, look at 0 radians. So if I look at rotating through an angle of 0 radians, that's an angle right here, right? Because I did not rotate that way nor that way. So what is my sine value at 0? 0. What is my cosine value at 0? It is what? 1. Was 0 over 1? 0. The tangent of 0 is 0. All right, so we're gonna learn that unit circle. We're gonna memorize it because we're gonna see it in this course and we're gonna see it in other math courses we take, especially those of y'all going on the calc. You're gonna see this over and over and over again. Identify the ordered pairs on the unit circle corresponding to the point. Identify the ordered pairs. On the unit circle, corresponding to each point. Part A, they give me t is equal to pi over 3. What is the ordered pair on the unit circle that goes with a t value of pi over 3? Let me draw a unit circle. here's my unit circle, like 1, 0, 0, 1, -1, 0, and 0, -1. All right, now what are they talking about the t-value? Remember they had that number line right here with some t-values on it. And they're saying in this case, t is equal to pi over 3. But what did we talk about on the unit circle? The t-value is the same as that theta value, right? So we could look at this like a theta value of pi over 3. Because remember this wraps around and that corresponds to that, right? So if I have a theta value of pi over 3, let's think about what we just had to memorize. This point right here, pi over 3 radians. What point is that? That's the point 1/2 comma square root of 3 over 2 if we memorize it. So what is the corresponding point that goes with t is equal to pi over 3? It is 1/2 comma square root of 3 over 2. Let's look at B. B is going to be t is equal to 2 pi over 3. All right, let's go ahead and draw our unit circle here. Ugly unit circle, but it's a unit circle. Remember, this is point 1, 0. This is the point -1, 0. This is the point 0, 1. And this is the point 0, -1. Remember these t values on the unit circle would be the same as that angle value, right? That theta value. So if I have a t value of 2 pi over 3, it's like having a theta value of 2 pi over 3. Now, think about this. This is pi over 2 radians. If we rotate around the circle to that, we rotate around the circle this far, that's pi radians, right? What am I looking at? I'm really looking at 2/3 of a pi, right? So not quite a whole pi here I'm rotating. It's 2/3 of one. So where is that going to put me? It's going to put me somewhere around right here. Call that angle theta is equal to 2 pi over 3. Now, which point am I at on the unit circle? Well, I don't know. You didn't have us memorize those. Yeah, but I told you it's going to be a quick way to figure them out if we end up just memorizing that first coordinate of a unit circle. And here's how we're going to do that. We're going to think about this. We're going to think about the regular old unit circle that I had to memorize, okay? Think about the regular circle, unit circle I had to memorize. And one of the values I had to memorize on that unit circle was theta is equal to pi over 3. We said if theta is equal to pi over 3, which point do we have here? 1/2 comma square root of 3 over 2. Now, if I'm thinking about a point over here with a reference angle of pi over 3, remember that acute angle formed by the x-axis and a terminal side? Then this point right here is moved the same amount right here as this one is. So it's going to have the same absolute value as the x value here because it's the same units away x-wise. And it's going to be the same amount of units up as the other point. So square root of 3 over 2. Its y value is going to be the same, right? Now, the only thing is, over here, if I go this way, my x value is going to be what? Negative. But my y value will stay positive there. So what are we saying there? We're saying that this reference angle pi over 3 has the same absolute value coordinates as my angle pi over 3, but we just have to adjust the signs on it. So what is the reference angle, back to this circle, what is the reference angle right here? Wouldn't it be pi over 3? So I know these ordered pairs are going to have like a half in them and square root of 3 over 2 in them, right? But what is the x coordinate here? It is negative. So what is the ordered pair that corresponds to this t value? Well, it's going to be negative 1/2 comma square root of 3 over 2. Let's look at C, 7 pi over 6. C. 7 pi over 6. T is equal to that value. All right, let's think about a unit circle. Here's my unit circle. Here's pi over 2 radians. Here's pi radians. Here is 3 pi over 2 radians. Here is 2 pi radians. All right, so I want to go through an angle 7 pi over 6. Wasn't that 1 and 1/6 pi? So what does that mean? From here to here is 1 pi, right? But I want to go a 6 more, so I'm going to go this much more. And let me draw that. I got some point right there, okay? That's 1 and 1/6 pi, I can say, that theta value. Now, what is this reference angle going to be right here? Wouldn't it be, change my color here, wouldn't it be 1 and 1/6 pi? But then I want to take away all of that much, so take away pi. So what's 1 and 1/6 minus 1 pi? That'll be what? Pi over 6 for a reference angle, right? All right, think about your unit circle. You had to memorize that one quadrant in. You had to memorize that one quadrant, right? And what did you have over here? You had pi over 6 here, which corresponded to the ordered pair square root of 3 over 2 comma 1/2, right? So if I'm displaced that much, I have these points. So if I'm displaced that same amount right here, I have the same absolute value, square root of 3 over 2 comma 1/2. But what's negative in quadrant 3? Is the x negative? Is the y negative? What? Actually, they're both negative, right? So put a negative on both of those. So the order pair that goes with this is what? Negative square root of 3 over 2 comma negative 1/2. And we're going to end the lecture there today since we had a quiz, because we don't want to take up the whole class period or whatever. So you'll start on the homework for this section today, and you'll continue back with it Monday after I post Monday's lecture. Y'all have a good weekend.